graph lines? No, that was the way that third hour said it right off the bat too. Put 2 points and connect them. What's the equation of a line? Let's think about it this way. That's what I was thinking about. So you graph lines with y equals mx plus b, where m is your what? Your slope. Now slope, remember, is the change in y over the change in x. So it's your rise over run.
Don't do it.
You may go hang it now as well. Probably have to move somebody's. You can pull bomb stuff down. She's not going to wear anymore. If you want.
No, pull holders down.
Well, then we'll pull
Nobody
holders
likes
down later.
Hi, Kayla.
Ouch. All right. So your slope is your change in y or change in x. Remember, rise over run. A lot of you guys can forget that. And b is your jock that jumps out at you. You might want to leap over that. What's nice about y slope intercept form is that it's always in that form of y equals, which means that there is a button on your calculator that says y equals, which means you can get tables and it helps you figure out a lot of stuff. Now, it's not always the most convenient thing to do, because you also have another form of equations that can be written out as what another way we write it out is called standard form. Ax plus by equals c, where a and b both can't be 0. A is pi.
Should we make the A and B?
Yeah, those are always countable. Okay. You don't need to remember all the other stuff on that one. All you need to know is that this is called standard form. And I think I alluded to the fact of this at some point in time before we went on break, is that standard form is a very easy, useful way to graph. We use standard form a lot because they give us standard form a lot of times, and you're able to what's called quick graph. For example, let me show you. If I have an equation in standard form, let's say it's 2x plus 3y is 12. And I want to graph that line. In past, you guys would solve for y. Get your slope, put it in slope intercept form. Well, that takes kind of forever. So we use, in standard form, is we're going to plot the intercepts. What I mean by that is, in order to figure out your y-intercept, what's the value of x when you're on the y-axis? 0. Your value for x on when you're on the y-axis is 0. So if I cover that up and solve for y, what do you get? 4. What's your y-intercept? 4. When you cover up the y value, that means you're solving for your x-intercept. What's your x-intercept? 6.
So you can do this because you're saying like when y equals 0.
Yep.
Okay.
What you're doing there is you're figuring out what the graph of the line is going to look like by just plotting the intercepts. It is. It's called quick, and that's the whole point. It's called quick graphs. Because a lot of times you're just looking for a visual representation of what something's going to look like. Okay? You don't have to mark out and walk out every single value. You're just figuring out directionality and seeing where it's going to lead. The other thing that we do a lot of in here is we start dealing more and more with inequalities, solid dotted lines and things like that. For example, if I have the numbers that work cleanly. If I wanted to plot this, notice I'm not giving you graph paper. You don't need graph. You don't need it. You don't need it. If I do the same idea of quick graphing, what's your y-intercept? What's your x-intercept?
6.
Now, when I connect these two, since I'm working on an inequality, will this be a solid or a dotted line?
Dotted.
That's solid.
I think dotted.
dotted. Dotted line. Now, when you have to figure out what happens next is that your graph with an inequality splits the XY grid into two separate planes. You guys remember a plane? Plane is basically something that goes off in 2 dimensions in all directions. Your XY coordinates is a plane. Yes, ma'am. Because it's less than. It's not a less than or equal to. Remember when you did your less than problems, you just open circle and you point the arrow? It's the same basic idea. Remember when you did this, and you'd say 6y is less than 18, y is less than 3. We plot it on the grid, you put 3 here, here's 0, and it's going that way.
Oh, the box.
Open circle. If it was less than or equal to, it would be solid.
Oh.
Same idea.
Okay.
Okay, it's the same exact idea. So here, it's a dotted line, but I still have to figure out what side it's shaded. The line itself creates 2 half planes. On one side of the plane is true, the other side of the plane is false. You always want to cover up the truth. You're shading. That's what you do. So you pick a point not on that line. What's a point that's not on that line that's really easy to work with?
0, 0.
What's 0 plus 0?
0.
Is it smaller than 18?
Yes.
So I shade towards that point. That's it.
So if you did like 3 and 6,
If I use 3 and 6, then it would be somewhere up here.
yeah.
9 plus 36 is not smaller than 18, so it's false, so I shade on the other side.
Yeah, then you did 6 and 3.
Okay. The easiest thing to do is if it doesn't go through your origin, use 0, 0.
Okay.
Now, the other thing that you'll do is we're also going to work with what's called, let's just see, a system. And we're going to put basically 2 graphs on the same grid. And you're going to look for your shaded overlap. Where do they overlap one another? Okay. Now, in this example, I have y is less than 3x plus 3, and y is greater than x minus 1. They're both in slope-intercept form, right?
Yeah, so do you have to change it?
No, just plot the slope-intercept. It doesn't have to be absolutely perfect. First graph, what's your y-intercept? 3. And what's your slope? So my first step is to go where? Down. Remember, rise over run. So you have to go up or down first and then go left and
So
right.
minus
I go down 3 over 1.
Oh, okay.
Down 3 over 1. Right here. It's my slope, -3. Well, when I connect those dots out, then is it solid or dotted? It's dotted. Does it go through your origin? Nope. So is 0 smaller than 3? Yeah, so it's true at the origin, so which way do I shade? Okay. What? You're looking at me like all like that. I went down 3 more and went over 1. Slopes. On the other one, my y-intercept is now -1, and what's my slope? 1. So I start at -1, up 1, right 1, up 1, right 1. Is it solid or dotted? Does that one go through your origin?
No. And then you do minus 1 is. Oh.
Yeah, so you go
Wait, and then can you?
Wait, hold on.
Oh.
Why, I don't know, I just graphed y is greater than x minus 1, and I haven't shaded it yet, and you're all freaking out. My y-intercept is -1, my slope is 1. I go up 1, right 1, up 1, right 1, and I connect the dots. La 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 la. All right? Does it go through the origin?
No.
No. Is 0 bigger than -1?
Yes.
So I shade above.
That whole area there.
Wait, how did you do a 0? Like, because I
And then
understand
you
that
substitute
you
it.
All good is substituting it.
Oh,
And then you can substitute
Yeah.
it.
A lot of times when we do their Christian, I'm going to say it out loud because it's, a lot of it's be really easy mental math to figure out.
Yeah.
All right?
So then where it's.
And where it's double shaded would be all points within that double shaded region are valid points for both equations. And that's what we're looking at.
So do we like circle it?
No. So like that. Yeah.
Didn't we did this in? I think we did it.
That was algebra.
No, it was never received.
Think about it. Let's do another one.
Wait, so we're entering all points that are double shaded?
No, you're just graphing it.
Just leave it like that?
Yeah, because that's what the answer is. But then we throw in things like this.
What? Is it just saying that about the?
About what? There's 3 of them. That's all.
The equations?
3 equations, yes.
Okay.
So when you have x equal a number, is it a horizontal or vertical line? Yeah. Vertical. So x is greater than 0. That's a vertical line. There. And what direction are numbers bigger than 0? So what I want you to start to do is just draw an arrow. The reason I want you to start drawing arrows is because these graphs are going to start to get messy. And if you have 3, 4, 5 graphs on one grid, all that extra shading is going to become a big pain in the butt. So we try to clean it up a little bit. Just show arrows. Okay? Y is greater than or equal to 0.
It's going up.
Moving up.
Oh, I get it.
So right now I have the region in the first quadrant is my overlapped region. Everybody see that?
You want those lines dotted?
What's that?
You want those lines dotted?
Are they supposed to be dotted?
No.
Why?
Yeah.
Is equal to.
Oh, it's better than orange.
They're not going to be
Oh.
dotted because these guys are equal to. Yes, ma'am. Yeah. You want it? It's fine. But remember, you have to make sure the dotted are solid though. But if you want to change colors, it's okay. Now here we have our -x plus 2y is less than 8. It's set up in such a way to do your quick graph. What's your y-intercept? What's your x-intercept? Solid or dotted?
Dotted.
There you go.
Oh, and then you plug in like 0, 0.
Did it go through the origin?
No.
So what's 0 plus 0?
0.
Is it smaller than 8?
Yeah.
So now it's moving down this way. So you wind up with this region bounded in here.
Nice.
What's that?
Change that last one. Wait a minute. So
No,
you-
I did quick graphic because it's written in standard form. I had covered and solved.
Do you only shade the like area with all the arrows? Like,
Yeah.
you know what I mean? That's
So
all.
what happens now is, if you want to think of it a little more clearly, it's solid here, it's solid here, and then it goes, it's an open dot here, and it's dotted out here. So this is your shaded region in here.
So where all the arrows are coming is your answer?
Is your complete overlap. Yes, sir.
Is that what we're looking for when we do these?
And that's the idea when I was saying you don't have to completely shade because it starts to get real messy the more graphs you put on there. By putting in the arrows, it starts to become a little bit cleaner. Just point you up. bad pun, point you in the right direction of where it's going. Right?
Third quarter of everything.
Oh, gosh. I'm so glad we don't have like.
Okay.
Every day you can live so far. So that I got some of my motivation.
All right. Do this one. Get your region here.
Who either love one variable?
Remember, when you have one variable, it just tells you have vertical lines or horizontal
Yeah,
lines.
that's what I'm saying.
Yeah. So here you've got
Yeah.
x is greater than -2.
Yes, but
It's going this way.
Oh.
X is less than
yeah,
5.
same thing. Variables going up.
Because it's gotta be greater.
Where are numbers bigger than -2?
Oh, never mind.
Same thing coming inward then. Greater than -1. Moving up. And less than 3.
Someone's had to go home and do homework.
This is the only classification.
So right now, you've got this shaded region that's bounded by this rectangle. Do you agree?
Yes.
Could you tell me the coordinates of the vertices?
Yes.
All right, what's this one?
That's
-2,
-1.
-2, -1.
What's this one?
-2, -2 and 3.
No.
5,
5, then
-1, -1.
5 and 3.
Do you want us to do that for these?
Not yet, but you're gonna need to start doing that when we get into our straight problems.
What?
We'll get there.
What do we do for problems like that where it's like inequality, you don't have,
Wait.
where instead of being x is equal to or greater than, it's just greater than, so you can't give them.
You can still see where they would intersect, even though it might be like an open dot.
Okay.
You know where that boundary is.
What is this? The short?
Yes, sir.
What is this like called? What's the term
Um,
we're doing right now?
What we're doing right now is just graphing systems of inequalities,
Graphing system related.
but it builds into what we call linear programming in a little bit. This is a little bit what we call our prerequisite skills, if you will.
Oh,
All right?
now you're sounding like this.
It's not like I know what I'm talking about.
But I don't.
All right, so this one here is a little bit different. You start out with some pretty simple x and y intercepts. Everybody agree with that?
Yeah.
At 8 and 8. So it's solid.
Oh no,
What direction is it moving? It's moving inward or outward? Shaded. Moving, what I mean by inward is because when I say inward, is it going towards the origin or away from the origin? Towards, so it's moving inward. Now the next one, if you do your cover and solve, you get y-intercepts and x-intercepts at 0. Doesn't help you, does it? No, this one doesn't help you on that. What you want to do here, with this equation, solve it for y. So you have 2x is greater, 2x is greater than y. Do you agree with me on that?
Yes.
Read it backwards.
y plus.
Now it looks like mx plus b, doesn't it?
Yeah.
What's your y-intercept? 0.
0.
Still y-intercept of 0, but your slope is 2. So you go up 2 over 1, up 2 over 1, up 2 over 1, wherever. And then it's a solid or dotted line.
Dotted. Ooh, this is like, come on, goes through. Like a teepee.
It goes to the origin, but what point doesn't it go through?
1.
What about 1, 0? Right?
Yes.
So if I use 1, 0, if x is 1 and y is 0, is 0 smaller than 1?
Yes.
Yes. So let's go this way. We okay with that?
Yeah, that's fine. Yeah. How did you grab the second one again?
I solve for y. Because if you do your quick graph on that, you get an x
So
and y
y
intercept.
is less than 2.
Yeah.
So,
It's slope intercept form right there with the intercept at 0.
Isn't it the intersection?
8 and 8.
and then just, slope 2.
Yeah. And then lastly, I have y is less than 4. So I just need to figure out that ordered pair right here. And this ordered pair here. Now what's nice about this is that you know that your y value for this ordered pair is something comma 4. And this one is something comma 4. In order to figure out
We don't have to be having a twin right now.
what's that?
Oh, never mind. I got the axis.
Since I know that my y value here for this ordered pair has to be 4 because it's on the y equals 4. Yes, ma'am.
Did you say we need to know how to do this, but we don't actually have to find the points right now?
No, I'm showing you how to find the points as we get into this, because the more and more we get into this, we need to find the points.
Okay.
You're okay with it knowing that the y value for this ordered pair is 4 and this one,
Yes.
because it's on the line. All you have to do then to figure out the x coordinate is realize that it's intersecting that equation. So if y is 4, what's x? 4. The other one is intersecting this equation. So what's x?
2.
2. Using some quick substitution, you're able to figure out what your x values are. Yes,
So
ma'am?
we just make it into an equal sign and.
Yeah. Yeah, you're just figuring it out. That's all.
Wait, so where do you want?
In this case here, you wind up with a little funky,
Like,
kind of a trapezoid-ish
Yeah.
thing. Shading downward, you got a dotted line here, solid there, and going from there, and it's moving. It's all open going down, because I don't believe there was a boundary below. So there's no,
see, you.
in this case, there's no minimum value, because it's open-ended on the bottom.
You did what I did. You did a little bit up to. You started.
Oh, okay. What this is going to allow us to be able to do are going to be problems like this.
Wait, is this our road?
Yeah. We're going to find what I'm going to do here is we're going to find a maximum and minimum value of what's called a constraint. This constraint is always given by the equation C equals something. What are you trying to maximize? What are you trying to minimize? Eventually, we're going to talk about maximizing profits, maximizing units sold, things like that. Tonight, these constraints, this C equation, will be given to you because you're just going to graph things, find ordered pairs, and substitute in. Tomorrow, when we start to build and develop out of the word problem, you're going to develop your own constraint. And after you do one or two of them, it's usually pretty easy to set up the constraint. The rest of the equations that you develop tend to take a little bit longer. But every one of these problems will be solved by using these inequality style graphing. Okay? Yes, sir?
What's the C?
I just said that's the constraint. What we're looking at here, that's the equation we're going to find the maximum minimum of
Oh,
within these four
okay,
equations.
all right.
So what we're doing here is we're creating a boundary. We're going to create a boundary on paper and find ordered pairs where all these things intersect, use those ordered pairs within a constraint to maximize it. Okay? Looking at the first value here, does everybody agree x is greater than or equal to 0, y is greater than or equal to 0, which means what quadrant will I be in? First. Just right off the bat, by looking at this, you know that this has to be a first quadrant problem because it's going from here to here. If you want to draw out the whole thing, that's fine. There's absolutely nothing wrong with that. My second equation tells me I have a y-intercept where? Correct. And what's my x-intercept? Will it be solid or dotted going through it?
Solid.
Duh, yes.
Sorry.
It's okay. I just hear me out for 1 second. I know that this part of the graph has no bearing in the problem. So I don't really need to know that. All I need to know is the direction it was going. Okay? It's okay. You put it there, it's fine. It's not a big deal. Check your shading. Does that line go through the origin? No. What's 0 plus 0?
0.
Is it smaller than 15?
Yes.
All right, so shading downward. So we're working down this way, out this way. Are we okay with me so far?
Yes.
Do the last one. The last one you have a y-intercept of 6. Oh, I'm sorry. Sorry, 12.
Sorry, I don't know what I was thinking.
I don't know, but you sold it. I believed you for some reason. So 12. So we'll put it, oops. Say 12 is here. And that's the idea. It doesn't have to be perfect. You're getting a visual idea of what it looks like. You don't have to mark all these off. Space it out a little bit and go for it. What's your x-intercept? 6.
That's where you got the 12. Or the 6.
And notice I'm plotting through my ordered pairs and going, hi! I missed this.
Come on in.
Thanks. You guys are the best. You do a great job. Don't let anybody tell you you don't. You're welcome.
Oh, flex pass. That's like one business.
And now I text them. Now I connect them. Do I solid or dotted?
Solid.
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 Right there.
Okay.
Zeros.
That right.
Now, is it go through the origin?
No.
So what's 0 plus 0?
That's right.
0.
Is it smaller than 12?
Yes.
So we have
Oh my
a
god.
shaded region inward here, bounded by these 4 ordered pairs. The only one we don't know is this one. In order to find that one, that's where the two equations, negative x plus 3y is less than or equal to 15, and 2x plus y is 12, intersect. So you need to solve the system of equations.
Oh, I love this stuff.
Let me show you. What we're going to do is solve the system of equations of negative x plus 3y is 15, and 2x plus y is 12. When I'm solving these things through like this, I'm going to put them as an equal sign because I'm just looking for where those two lines are going to run into each other. You don't have to, you can do it that way if you want. There's multiple ways of solving systems of equations. What Allie's talking about here is called linear combination. You multiply it and add them together. Or you can use substitution. Okay. In this case, I use substitution third hour because I just moved the x and I moved the 15.
So that makes sense. I never thought of it that way.
And your way would work as well. Okay, your way would work as well. What I'm doing here is I'm going to take this first equation. Oops. I'm going to take the first equation, add the x, and subtract the 15. So I have 3y minus 15 is x. So I take this value there and solve for y. Everybody see that? I'm using direct substitution. It's usually the method most people don't screw up.
Oh, I see.
Okay. Now I figure out what the y value is by, let's see, we have 6y minus 30 plus y is 12, 7y, 42, y is 6. So I know the y value here is going to be 6. Figure out the x value, I just resubstitute back in. or either one of them, sorry. 3 times 6 is 18. 18 minus 15 is?
3.
3.
Oh, I did it in the way where you get rid of this.
Oh, I see what you're saying. And you're done. So now you have 4 ordered pairs. Well, I shouldn't say you're done. We have to find the maximum and minimum.
Oh, wait, so the ordered pair is just gonna.
What you want to do now is just, I'm going to put this back on the full screen. What you want to do now is list out your 4 ordered pairs. Or some problems you have 3, some problems you'll have 5. You don't know it until you get going. We have 0, 0, 6, 0, 3, it was 3 and 6, correct?
Yep.
And 0 and 5?
Yeah.
Thank you. And we're going to check it with this constraint function. We're going to substitute in 2 times 0 plus 3 times 0. 2 times 6 plus 3 times 0. 2 times 3 plus 3 times 6. And 2 times 0 plus 3 times 5. You're checking the value of each one of those ordered pairs into the constraint. So what's 0 plus 0? 6 and 18. 4. Where's your maximum? Where's your minimum?
24 and 0.
There's your answer.
Oh, that's cool.
There's your max. And there's your min. What these things allow you to be able to do is if you, let's see, I have an example. If you want to make a gift basket for your mom who's an avid reader, you decide to include hardcover paperbacks in the basket. You have $80 to spend. Each hardcover is $24 and each paperback is $8. The basket will hold at most 3 hardcover or 7 paperbacks. Find the maximum number of books you can include in the basket. That's all this is. You're maximizing the number of books you can put into a basket. And that's your constraint. Okay? If you're talking about you sell granola bars. You sell peanut butter chocolate chip granola bars for $1 and you sell s'mores granola bars for 75 cents. You can only have X amount of these, X amount of those. You want to maximize your profits. How many of each do you sell? And so on. That's the kind of things that this allows you to do. Right? Try this one real quick. We got a minute.
I don't want to turn the page, so.
Just turn the page. It's not going to kill you.
Well, then I can start my.
It's gonna kill the trees. Yeah.
You'll get over it.
Oh, I haven't opened.
You know what? We're gonna buy a tree and plant one. So that way every time I say, who cares? Because I'm building a tree.
Building the tree.
Shut up.
How's that going?
You know what I mean.
No.
Nobody asked you.
Oh.
Yes, I did ask you.
Yeah.
Yes, ma'am.
It's gonna be 4 lines.
Wait, so you only want to
Sliding
mix?
What's that?
Just one six.
Yeah, this one says max. Sometimes it says maximum, sometimes it says minimum.
Natalie, do not.
That's right, we were just singing that. No, she
No,
wasn't.
I was not. I would never sing.
What were you singing then? Don't mind.
I'll have to look through it.
I'm sorry.
It's okay. I'm gonna walk through this a little bit quicker, so we're running a little bit out of time. Greater than 2. Less than 5. Greater than or equal to 0. And we're at 12.
Okay, so the y-intercept
Let's see,
would be
2x, so 2x plus y, so we have 12 and 6.
-6, right?
No, positive.
Oh, I'm sorry, I messed up. I didn't have to do that.
Everybody everybody see what I did there with that last equation? I quickly put it in standard form just to plot zeros. Because I'm just cutting through it. Because I've got, if I use 0 for that, is 0 going to be smaller than 12?
No.
Wait, yeah.
So I know that this is bounding itself inward. So I have this nice region here. Well, it's not a triangle, but it's close. It'd be a quadrilateral. Actually, it's a trapezoid, but yeah.
Still quadrilateral.
Thank you.
I hate math.
We know, definitely know 2 of the ordered pairs without worrying so much. We have 2, 0, 5, 0. What's the x value vertically from the 5, 0? 5. Because it's vertical.
And then 2 sign, the other one.
So if I substitute in 5 for x, what's negative 2 times 5? What's negative 10 and 12?
2.
Do the same thing vertically as a 2.
Yay.
Negative 4, 8.
I love it.
It's 2 and 8. So you have 4 ordered pairs to test to figure out where your maximum value is going to occur.
And then you plug it into the C.
Well, if you're doing electrical work, you would plug it in. But yes, if you substitute in, you would probably get the right maximum. It's section 3.4 in the book. It's page 166. I'd like you to do numbers 12 through 20. It's all constraint ones like this. You're going to find maximum and minimum value. The first 4 or 5 of them are really, really fast. About midway through, they just take a look. They're not very difficult. They take a little bit longer. I think the last one might give you a fraction that you have to find for a value. Okay. We'll take this and parlay it into working with word problems tomorrow.
Wait, Hannah, so are you going to get your license today or no?
No. She's still in driver's ed.
Is it your birthday too?
Yeah.
Oh, happy birthday! We went the whole class. I didn't know that. I would have put like a birthday crown on their picture.
Print another one out with a crown on it. There it is.
There's 12 birthday.
Girl's so short. Did you guys win against Michelle?
It's like
What?
Is that even a question, Natalie?
That's like I was from, no one was on base. If someone was on base, we would have won. But no one was on base. Oh yeah. Yep. And we lost your
Like really bad or something.
They're like 7 and 1.
We're not bad.
Is that better?
We're actually really good, except for we just make mistakes. We have
You're really good, except that doesn't usually start out like a good conversation. Oh, we're really good, except.
we make stupid errors that we shouldn't make.
If you want to go grab this for yourself, it's on the.
It takes like 5 minutes to print that.
Well, then never mind. See you guys.
I had a question.
Yes, ma'am.
What was wrong with my
I
equation?
like to choose I want that.
It's a 2 factor, not a pi factor.
Okay.
That's why.
I like to flip it away.
See you guys. Have a good one.
I have a quick question about
Yeah,
the
bud.
test. This one, how did I get this wrong?
Let's hear this. You didn't tell me any of your asymptotes.
I put one right there.
But you didn't label out the shift you didn't tell me where the shift ones were or anything like that. There's no, you gave me one of them, but you didn't give me, you have to list out your 2 original asymptotes and your 2 shifted asymptotes. So there's 4 values right there. You gave me one of them.
Okay.
That's, all right.
Wow, I lost a lot of points with that.
I tried to make that one really, really easy so you guys wouldn't make a silly mistake like that, but you made a silly mistake.
Yeah.
Oh well. We'll see you later.
I see that.
Hello? Hello.
How was your spring break?
Good. Yours?
Pretty good.
What did you do?
We went up to Wisconsin for a few days. Other than that, just kind of hung out.
Oh my God.
We went up to Minocqua. We went a lot further than that. The Dells is halfway. Yeah, no, we had a good time. We have relatives that own a couple of places up there, so we were up there for a while. It's beautiful. We go up there all the time. Did you have a good time?
I went with my RA.
Nice.
I'm an expert on this one.
Get the bag.
I think I have a couple. Yeah, I have a few extra certificates. What's in the box? You know what's in the box. Well, you're not gonna know what's in the box. You don't get to read this. Well, then you don't get to be an expert.
You said I checked it.
Maybe I'll walk.
Worked with my mom.
Flesh or flesh?